Download this code from codegive.com, link in the description below. BS18, Allocate Books Problem. The allocate books problem is a common problem in competitive programming and interviews. The problem can be framed as follows. You are given n books, each with a certain number of pages, and you need to allocate these books to m students such that 1. Each student gets at least one book. 2. You want to minimize the maximum number of pages that a student has to read. The goal is to find the minimum possible number of pages that a student has to read while ensuring that the books are allocated in a way that fulfills the above conditions. Problem breakdown. 1. Input. An array books of size n, where books I represents the number of pages in the ith book. An integer m representing the number of students. 2. Output. An integer representing the minimum number of pages that a student has to read. Approach. To solve this problem, we can use a binary search approach. Here's a step-by-step breakdown of the algorithm. 1. Define search space. The minimum possible answer, low, is the maximum number of pages in a single book since at least one student must read that book. The maximum possible answer, high, is the total number of pages in all books, which is the scenario where one student reads all books. 2. Binary search. Use binary search on the answer space. For each mid value, which represents the maximum number of pages a student can read, check if it is possible to allocate books to students such that no student reads more than mid pages. 3. Feasibility function. Implement a function to check if a given max page count is feasible. This function will try to allocate books to students such that no student reads more than the specified max pages. Code example. Here's how you can implement this algorithm in Python. Python. Def is _feasible, books, n, m, max _pages. Student _count equals 1. Current _pages equals 0. For I in range, n. Check if adding this book exceeds the max pages. If current _pages plus books I max _pages. Assign the book to a new student. Student _count plus equals 1. Current _pages equals books I. If we exceed the number of students, return false. If student _count m. Return false. Else. Current _pages plus equals books I. Return true. Def allocate _books, books, n, m. If n m. Return -1 not enough books for students. Low equals max, books, the least maximum pages. High equals sum, books, the maximum pages if one student reads all. Result equals high. Initialize the result as the maximum possible. While low equals high. Mid equals, low plus high, / 2. If is _feasible, books, n, m, mid. Result equals mid. Update result as we found a feasible solution. High equals mid, 1 try for a better, lower, answer. Else. Low equals mid plus 1 increase mid as it was not feasible. Return result. Example usage. Books equals 12, 34, 67, 90. M equals 2 number of students. N equals len, books. Min _pages equals allocate _books, books, n, m. Print, f minimum pages a student has to read, min _pages. Explanation of the code. Is _feasible, this function checks if we can allocate books such that no student reads more than max _pages. Allocate _books, this function initializes the binary search parameters and calls the feasibility function iteratively to narrow down the possible answer. Input, you can change the books array and the number of students M to test different scenarios. Complexity analysis. Time complexity, the time complexity is \o and \log, \text sum of pages, where and is the number of books. The logarithmic factor comes from the binary search over the range of possible answers, and the linear factor comes from checking feasibility. Space complexity, the space complexity is \o1, since we are using only a constant amount of space. This method effectively finds the optimal way to allocate books to minimize the maximum number of pages read by any student.